Hello people, so today we will talk about electric field lines. In the last video we talked about the dipole which experience the torque in the electric field. So today we will talk about electric field lines. So what we know that what electric field is, but what is electric field lines? These are the imaginary lines which represents the electric field. So we will talk about the electric field lines and we will discuss some of the properties of it, by which we will get clear about what electric field line is. First property, the line of forces are continuous smooth curves without a break. Suppose a positive charge. This positive charge creates an electric environment around it, and these lines are representing the electric field which is going away from the positive charge. We can see that these lines are continuous without any break and they are smooth, and we will talk about these lines when they form curves later. So this property shows that these lines are always curved, smooth and continuous. The second property is the line of force starts at positive and ends at negative charges. Suppose 2-point charges, a positive one and a negative one. This property tells that the electric field lines are always represents that the electric field is going from positive charge towards a negative charge. So lines are always from positive to negative. We know that the dipole always works from negative to positive charge, but in electric field lines always go from positive to negative. There are for the more lines. So there is a important point which says that electric field lines never forms a loop. Suppose a positive charge and a negative charge. Again, if we are forming a loop, like the electric field lines are going from positive to negative and then again negative to positive, this means that electric field lines are starting from the infinity and ending at infinity itself, which is not possible. So the next property is the tangent to a line of force gives the direction of electric field. So this means that suppose an electric field line which is due to some charge. Now if we draw a tangent to this line, this electric field, now this tangent gives the direction of the electric field. This line shows that where the electric field is working. This is working in that direction, and this electric field line is making a curve. I talked about this curve in the first property. The next point is the no lines of force cross each other. So take electric field line and let's draw a tangent. This line says that no two electric field lines cross each other. Suppose they cross each other. We are just supposing it. Suppose it is crossing, and let's draw a tangent. These both shows that the direction of electric field lines are in the different directions, which is never possible. So this property states that the lines of force never crosses each other. So these were some of the main and important electric field lines properties. Some of the other properties are also there, but like the lines of forces do not pass through a conductor because electric field inside a charged conductor is zero, and the closer the electric field lines are to each other, the more would be the electric field around these lines. So now we will talk about the electric field lines for different charge conductors. Suppose a positive charge. This positive charge shows electric field lines away from it, as we have talked in the property that electric field lines are always from positive to negative. So this shows electric field lines away from it in every direction. And if we suppose a negative charge, in the negative charge it is always from positive to negative, so the electric field lines would be towards the negative charge from the every point. Now what if we take two positive charges, one positive and another positive? We know that the electric field lines are always away from the positive charge, so we can draw the electric field lines going away from it, because no electric field lines cross each other, so they would be going away from each other. Like this. They are always away from each other. Now when we talk about two charges which are negative and positive, the electric field lines are always from positive to negative. So we can draw this in the form from the electric field line going from positive to negative in this way. So this diagram shows that the electric field lines are going from positive charge to negative charge, as the positive and negative always attract each other. So we can make and draw further lines going from positive to negative. Now what if there is a plain conductor? Let's suppose a sheet or rod which is positively charged. Now this conductor will represent the electric field lines away from it, so they would be parallel to each other and will form a uniform electric field around it. We know that as the electric field lines goes away from the conductor, the strength of electric field also decreases. So this is the diagram for a plain sheet, a positive conductor, showing the electric field lines are going away from it for the positive charged body. If it is negative, the arrow would be in the direction towards the conductor, the negative conductor. So thank you guys. I hope you liked the video. So just hit the like if you liked it and subscribe for more. I would be starting the videos for the Python. I will show you how to make the dictionaries, the lists, the strings, everything about the Python. So thank you.